11.2, page 594, Box and Whisker Plots. In this lesson, you will learn how to use a box and whisker plot to represent a data set, how to interpret box and whisker plots, and how to use box and whisker plots to compare data sets. So let's talk about what a box and whisker plot is and what it represents. A box and whisker plot shows the variability of data along a number line using the least value, the greatest value, and the quartiles of data. So here would be a picture of what a box and whisker plot looks like. Again, it's going to show how much data varies, the variability of it. The quartiles divide the data into 4 equal parts. I'm going to take a little highlighter and highlight that. You can see we have a first quartile here. That's the first quarter of the data. Here's the second quarter of the data. Here's the third quarter of the data. And here's the fourth quarter of the data. They break the data into quarters. Okay, the quartiles divide the data into 4 equal parts. The median divides the data set into 2 halves. You notice they've labeled the median here. So the median of this data would have been here, and so half the data is above that, and half the data is below that. The median of the lower half is the first quartile. So if I just looked at the first half of the data, which I'm kind of putting a box around, the median of the first half is right here. That's called the first quartile. And the median of the upper half, so let me take a different color pencil. You know, here's the upper half of the data. I'm boxing it in blue. The middle number in the upper half is right here. That's the median of the upper half. That's called the third quartile. So I threw a lot of vocabulary at you there. Might be good to draw this picture and just label the picture in your notes. The 5 numbers that make up a box and whisker plot are called the 5-number summary of the data. So we just talked about the quartiles and the median. In fact, maybe I should look at that page again. You know, the least value, the greatest value. That's called the 5-number summary. Now, luckily, we can use our calculator to get the 5-number summary. And actually, we've already learned how to do this. We did it in the last lesson. Let's do this problem together. We're going to make a box and whisker plot that represents the ages of the members of a backpacking expedition in the mountains. So you see how they gave us the ages. We can put this in our calculator, and the calculator will make the 5-number summary for us. So let's do that. Let's take our calculator out. And I reset my calculator because I wanted it fresh to put in this new data. So now we're going to put in those ages. The ages, to put those in, go to Stat, Edit, and we're going to type in the ages that we see right here. We're going to type in these ages. Okay, so I'm going to start typing them in now. So we had 24, and then 30, and I'm going to pause the video just so it's not long, and let's type in the rest of them. And you can see I've typed in all the data, and there are 12 numbers in the group. So now we want to find the 5-number summary. That's easy. We're going to do just what we did yesterday. We're going to type in Stat, Calc, 1 variable, Stats, press 1. On my calculator, I can press Enter. On some of yours, you'll have to scroll down to Calculate. And there's the average, and there is the standard deviation. But if I go down farther, here is the 5-number summary. Let me freeze the screen so we can highlight that. Okay? The minimum value is 18. The maximum value is 30. And if you see, that matches the picture in the book. You see how the end of the box and whisker plot is 18 and the top is 30. In fact, let's look at that. You can see it right here. There's the minimum 18 and the maximum 30. The median of the entire group of numbers is 25. That matches what they have in the book. You can see the median is 25. And the first quartile was 23. That's the median of the bottom half of the numbers. And the third quartile was 29. That's the median of the upper half. And if I look in the book, you can see the median of the bottom half was 23 and the median of the upper half was 29. I can use my calculator to get the 5-number summary and to help me draw the box and whisker plot. Now, when you draw your box and whisker plot, the first quarter of the data is a whisker and the last quarter of the data is a whisker. The middle half of the data, from the first quartile, I'll put Q1 up to Q3, that is a box. And then inside your box, wherever you see the median, that's where you draw a little line. That's how you draw a box and whisker plot. What I would like you to do is pause the video, and I want you to take this data of a basketball player, how many points he or she scored in each game, and I want you to make a box and whisker plot of this data. Pause the video and do that. And I'm back, and your box and whisker plot should look something like this, where the low value is 5, the high value is 30. Our first quartile was 13, our third quartile was 25, so there's my box from 13 to 25. The median score was 18, and I'll just draw whiskers off the end. There's my box and whisker plot. Now, how do we interpret a box and whisker plot? I've talked a little bit about it already, okay? This figure shows how data is distributed in a box and whisker plot. First of all, the whiskers are each 1/4 of the data. So the bottom quarter of the data is here, and the top quarter of the data is here. Okay? The long whisker indicates that data is more spread out. So if I look at this box and whisker plot, the data in the bottom quarter is more spread out than the data in the top quarter because this whisker is longer. Because what's important to know when you look at a whisker, what's that telling you? Half of your data, the middle half of the data, is in the box. So if you think about it, again, here's 1/4 of the data. I'll put little markers here. There's 1/4 of the data, so I'll put a quarter. Here's another quarter of the data. Here's another quarter of the data. And here's another quarter of the data. So if you put all quarters together, you have 1. Can you see how these 2 quarters create half? Half the data is in the box. Another measure for variation for a data set is interquartile range. Now, you've learned what range is. Range is taking the top value minus the bottom value. Okay, now interquartile range is taking the range of the third quartile and the first quartile. So in other words, you're going to find the range of the middle half of the data. Okay? So we can see an example of that here. Let's look at these problems. Interpreting a box and whisker plot. Here's a box and whisker plot of the lengths in seconds of songs played by a rock band at a concert. Let's find and interpret the range of the data. So here's the range. The high value is 300, the low value is 160. The range of the data is 140 seconds. So all the songs played at the concert were within 140 seconds of each other. Okay? Part B, describe the distribution of the data. The bottom quarter of the data is from 220 to 160. Okay? So that means that the bottom 25% of songs were in between 160 and 220 seconds. The top quarter of songs were in between 280 and 300 seconds. And the middle half of the songs, so half of the songs, the middle group, were anywhere from 220 to 280 seconds in length. Let's find the interquartile range of the data. Okay, so we're taking the top end of that half and the bottom end of that half and subtracting. 280 minus 220 is 60. So the interquartile range is 60. That means the middle group of songs, that middle half of the songs, varied by no more than 60 seconds, I meant to say. So all these songs in here were within 60 seconds of length of each other. Are the data more spread out in quartile 1 or quartile 3? Explain, okay? Can you see the whisker here? This whisker is longer than that whisker, so the data for quartile 1 is going to be the greater amount of data, okay, or the greater spread in the data. What I'd like you to do is pause the video, go back to example 1. That was the basketball player example. You've already drawn a box and whisker plot for that. I want you to go back to that and find and interpret the range and interquartile range of that data and describe the distribution of that data. So pause the video and do that. Okay, we're back, and first of all, the range of the data. The basketball player's highest point total was 30 and lowest was 5, so that person's range is 25. So they had a range of 25 points from 5 to 30 scored in different games. The interquartile range is a little different. That's taking these two numbers in here and subtracting. 25 minus 13 is 12. The interquartile range is 12. So the basketball player, he or she, her or his middle scores, anywhere the middle 50% were always within 12 points of each other. Okay? Now the first quartile goes from 5 to 13 points. So the bottom 25% of scoring efforts were from 5 to 13. The middle half was from 13 to 25, and the top quartile was from 25 to 30 points. Let's finish up the video by talking about how we use box and whisker plots to compare different data sets. A box and whisker plot shows the shape of distribution of data. So if we see a picture such as this one, you see how we have a long whisker on the left and a short one on the right, and you can see the median is more pushed to the right. You notice the left whisker is longer. That means most of the data is, let me highlight this, most of the data for this is packed over here. So this is called, we're skewed left because most of the data is on the right side of the graph. So it looks long on the left because all of our data is packed on the right. This is called skewed left. Now the next is symmetric. The whiskers are about the same length. Everything kind of looks even on each side. The median looks in the middle. This would be a symmetric box and whisker plot. And skewed right means that the data is more pushed on the left and we kind of have more spread data on the right. This is skewed right. Okay? So we can use that to approximate or to compare different sets of data if we have two box and whisker plots. It's important, I should mention here before I forget it too, symmetric. If you have a symmetric box and whisker plot, each side is going to be approximately a mirror image of the other. We have an even distribution of the data. So we can use that, we can use this to interpret a box and whisker plot comparison of two different sets of data, such as here. The double box and whisker plot represents the test scores for your class. So here's your class. Let me highlight it. This is your class, and then we have your friend's class. Identify the shape of each distribution. Well, your class is definitely skewed left. Your class is definitely this. Your friend's class is definitely more symmetric. Which test scores are more spread out? Well, your friend's class has a range of 40. Your class only has a range of about 32 or 33. Also, look at this. Half of your friend's class has scores between 70 and 90, where half of your class only has scores between 85 and 95. So the data is overall much more spread out in your friend's class, and you can see that here. I think I'm going to stop the video here. If you have questions, make sure you ask in class.